Okay, as we said in the other video, you may have more than one shape of the integration. It could be addition, subtraction, or composite. That was our first case. And it could be multiplication. Now, if it's multiplication, then we may have simple multiplication that can be simplified and then it can be integrated directly. Like this example, we can distribute the 2x by the bracket. That's a simple multiplication. So how am I going to integrate this? This is easy. Integration of 2x to the power of 5 plus 6x, all depending on x. Now it becomes addition between two simple functions that are ready to be integrated. 2 can be taken out, so it's 2 times x to the power of 6 over 6 plus 6x squared over 2 plus c. As you see, this is simple and can be simplified. So it's x to the power of 6 over 3 plus 3x squared plus c. Now, what if it was not simple to integrate, like to multiply, like this one? 2x times x to the power of 2 plus 3 all to the power of 7. What am I gonna do in this case? 2x cannot be distributed. So what should we do? If it's not simple, then we use substitution. How do we do that? By choosing the assumption u, then find its derivative, du over dx, then use that to simplify our integration. Let's try to apply that on our example here. I need to choose an assumption u, something that can simplify my integration. Look at what's inside the composite here. If I'm gonna call this u, what's gonna happen? U equals x squared plus 3. Derive it. That's derivative u depending on x equals 2x. Look at that. I have du and dx. If I'm going to call this part of the integration u, then it will be x and u and dx. So let's try to replace dx also. How am I going to do this? If you just cross multiply here, you will get 2x dx equals du. So if you divide by 2x, you will get dx equals du over 2x. Have a look at this and how it would change my integration. My integration is 2x times u to the power of 7 now. So it will be equal to integration of 2x times u to the power of 7 times, instead of dx, I can write du over 2x. Now, how would that help? Look at this, we can simplify. So actually we'll be left with integration of u to the power of 7 depending on u, which can be done directly. So that's u to the power of 8 over 8 plus c. Then replace it and you will get what was u. It was x squared plus 3. So x squared plus 3 all to the power of 8 over 8 plus c. How is that? I believe that this makes our life easy in case of multiplication. Now, the big question is how to choose the assumption y. Okay? Now, in case, I'll try to give you keys for that. Just keys, keep that in mind. These are not rules, just a way to think about it. If we have normal times composite, like the example that we did here, we had normal times composite, normal times composite. What did I choose? I did choose what's inside. Now, why did I do that? Why? Because when you derive what's inside, that has a possibility of giving you what's outside so you can simplify it. And actually, that's the main key of choosing an assumption. So when you want to think of an assumption, you have to think about it this way. Normal times composite. So what makes sense for us is to choose what's inside the composite without the power. What if I have a normal times an exponential What makes sense here is to choose the power, since when you derive the power, it has a possibility of simplifying with the normal. What if I have a normal times trigonometric functions, 2x times sine x squared plus 5, for example? Well, I think the angle in this case will solve the problem, so you just choose the angle of the trigonometric. What if you have secant squared times tan to any power? Think about it. What's the derivative of tan? The derivative of tan is secant squared. So what makes sense here is to choose tan without its power, because the derivative of tan can be simplified with secant squared. What if I have sine times cosine? Well, actually, any of them can give the derivative. The derivative can give you the other one, so you choose any of them. Or if one of them has a power, for example, sine to the power of 3 or cosine to the power of 3, you can choose the cosine, but again, without its power. Let's try to do some examples on this. If I have this example, it's multiplication, 2x times e to the power of x squared plus 3. It's ready. So what should I do with that? It's not simple multiplication. So immediately I have to choose u, and that's normal times exponential. So u will be the power of exponential. Derive it. That will be 2x. Cross multiply to get dx. So dx will be du over 2x. Now, this will make my integration equals 2x e to the power of u times du over 2x. And again, 2x with 2x can be simplified. So we are left with integration of e to the power of u depending on u. And e to the power of u has its own integration rule, so it's direct. E to the power of u divided by the coefficient of u, which is 1 in this case, plus c. Replace it, so it's e to the power of x squared plus 3 only. And of course, plus c. Okay, how was that? I believe that was easy. Now, what about this one? 3x squared plus 1 times sine x cubed plus x dx. Again, that's multiplication, not simple multiplication. So what am I going to do here? I have to choose u again, and u should be the angle of trigonometric. So u equals x cubed plus x. Derive it. Du over dx will be equal to 3x squared plus 1. Cross multiply to get dx, so dx will be equal to du over 3x squared plus 1. Now you can choose u, dx to make your integration looks easy. Integration of 3x squared plus 1 times sine u times, instead of dx you have du over 3x squared plus 1. Now again we can simplify to make our life easy. So integration of sine u du, and sine u has its own rule, that's negative cosine the angle divided by the coefficient of the angle. Since it's linear, we are done. So negative cosine the angle x cubed plus x plus c. That's it. I guess this is easy. Now a question for you. Try to apply what I told you on this question. Sine 3x times cosine cubed 3x.